Welcome to Data Science for Business Analysts. In this course, you'll discover how to turn data into smart business decisions. Meet your instructor. I am Dr. Kumar, a seasoned expert with over 10 years of combined academic and industry experience in data science. In this course, Module 1 is all about understanding data, the foundation of data science. You'll learn about data types, structures, outliers, balanced versus imbalanced data, and how to interpret it for real business impact. What is data? Data refers to raw facts and figures collected from various sources, which can be processed to gain insights or make decisions. In data science, data is the core element used for analysis, prediction, and visualization.
Data types. Data can be categorized broadly into three types. Structured data. This data is organized in rows and columns. Examples include spreadsheets and relational databases. For instance, sales data or student records. Unstructured data. This has no predefined format or structure. Examples include text, images, videos, and social media posts. Semi-structured data. This is not in a strict tabular format, but still has some organizational properties. Examples include JSON and XML files. By nature of values, numerical data. Discrete. These are countable values. For example, the number of students in a classroom. Continuous. These are measurable values. For example, temperature, height, or weight. Categorical data. Nominal, these values have no natural order. For example, gender or color. Ordinal, these have a meaningful order. For example, low, medium, high. Balanced versus imbalanced data. Balanced data. The classes or categories in the dataset are roughly equal in size. Example, 50% healthy and 50% diabetic patients. Imbalanced data, one class significantly outnumbers the other. Example, 95% non-fraud cases and only 5% fraud cases in a fraud detection dataset. Why it matters? Imbalanced data can bias machine learning models toward the majority class, leading to poor performance in detecting rare events. Outlier detection. Outliers are data points that differ significantly from the rest of the data. Example, in a data set of ages between 10 and 20, a value of 85 would be an outlier. Detection techniques include Z-score method IQR, interquartile range box plots, machine learning-based anomaly detection impact. Outliers can distort data analysis and reduce model accuracy. They may need to be removed or treated depending on the context. Data models. Data models define how data is organized, stored, and accessed. Types of data models. Relational model. Structured data in tables with rows and columns. Document model. Semi-structured data like JSON or XML. Graph model. Data represented as nodes and relationships. Example, social networks. Data analysis. Data analysis is the process of examining, cleaning, transforming, and modeling data to discover useful information and support decision-making. Types of data analysis. Descriptive analysis. What happened? Example, analyzing the average sales in a company. Diagnostic analysis. Why did it happen? Example, investigating a sales drop due to a price increase. Predictive analysis. What is likely to happen? Example, forecasting future sales. Prescriptive analysis. What should be done? Example, recommending discounts to boost sales. Common tools used, Excel, Python, with libraries such as Pandas and NumPy, R, Power BI, Tableau,